Hi, so we're going to be carrying on from where we left off, which is infectious diseases. Okay, we're up to the immune system dealing with pathogens. So, they have three roles. Number one is to consume them, where they engulf the foreign cells and digest them. Second method is they produce antitoxins, which counter the effect of any poisons produced by the invading pathogens. And finally, number three, which is unfortunately the longest, they produce antibodies. It's the one you need to know in depth. So every pathogen, so let's say this is a pathogen, has unique molecules on the surface of its cells, and no two pathogens are alike, and these are called antigens. When your white blood cells come across a foreign antigen, they'll start to produce antibodies, which will lock onto and kill the invading antigen. Then the antibodies are then produced rapidly and float all around the body to kill all similar bacteria because they know that that's bad now. Some white blood cells stay around in the blood after the pathogen has been fought off, which are called memory cells. And if the person is infected with the same pathogen again, then these cells will remember it and immediately make more antibodies to kill it. So this is immunity. Now we're on to immunization. Great spelling there. Immunization. Okay. Immunization stops you getting infections, and when you're infected with a new pathogen, like this one, it can take your white blood cells a while to produce the antibodies to deal with it, and in that time you can get really ill, maybe die. So to avoid this, you can be immunised, which is you might know as vaccinated against some diseases, for example measles, and it involves injecting dead or inactive pathogens into the body, which carry antigens. So they carry antigens, and even though they're harmless, they still trigger an immune response, which means your white blood cells produce the antibodies to attack them. Some of the white blood cells will remain as memory cells, so if live pathogens of the same type ever appear, the antibodies will kill them instantly. Immunisation is classed as active immunity. Active immunity is where the immune system makes its own antibodies, active immunity, after being stimulated by a pathogen. It includes being naturally immune and artificially immune, which is immunisation, which we just learnt about, and active immunity is usually permanent. Whereas the other type is passive immunity, which is where the antibodies are made by another organism, for example the mother to the baby through breast milk, and it's usually only temporary. There are benefits and risks associated with immunisation. The benefits are it stops you getting ill, which is great, and if most people are immune, the disease won't be spread as easily. But there can be short-term side effects. The side effects are swelling and redness at the site of injection and feeling a bit under the weather. You can't have some vaccines if you're already ill because your immune system will be weakened. And also, another risk associated, some people think that immunisation can cause other disorders. For example, one study suggests a link between the MMR, which is the measles, mumps and rubella vaccine, and autism. Scientists now know it's safe, but for a few years many parents weren't willing to take the risk. To get rid of some infections, you can take antibiotics. They are drugs that kill bacteria without killing your own body cells. They're useful for clearing up bacterial infections, however they don't kill viruses. Antivirals can be used to treat viral infections, so antivirals. And they are drugs that stop viruses from reproducing. Some bacteria are naturally resistant to certain antibiotics, which means they're not killed by certain antibiotics. Misuse, for example doctors overprescribing or patients not finishing the full course, has increased the rate of development of resistant strains, which means that nowadays you won't be able to get antibiotics for a mild infection, only something more serious. Now on to the next section. Cancer is caused by body cells dividing out of control. Okay, good diagram there. It forms a tumour, which is a mass of cells, so that could be a tumour, and they can either be benign or malignant. Sorry about pronunciation if it's wrong, I'm not exactly sure how you pronounce it. So first of all there's benign, which means the tumour grows until there's no more room. So if you have, for example, if you have a box and you fill a balloon inside it, and you can't blow it up any further than the box. The cells stay where they are and it's not normally dangerous. Whereas malignant the tumour grows, so like the balloon again, but it spreads outwards without the box, and it can spread to other places in the body. They're usually dangerous and can be fatal. Scary picture. To reduce the risk of getting cancers, you can have a healthy lifestyle and diet. For example, not smoking and eating less processed meat and more fibre. I will move that up so you can actually see it. There you go. How great is that? Okay, the last bit on this page is about testing drugs. Drugs developed to treat these need to be thoroughly tested before they can be used to make sure they're safe and that they work. So firstly, they use computer models and they stimulate a human's response to a drug, so you don't need to test on live animals. They can identify promising drugs to be tested in the next stage, but it's not as accurate as seeing the effect on an actual organism. The second stage is testing on human tissue, but the only problem with this is you can't use human tissue to test drugs that affect the whole body system. For example, testing a drug for blood pressure must be done on a whole animal, so one that has an intact circulatory system. Finally, the third test is to develop a drug using animals. The law in Britain states that a new drug must be tested on 2 different live mammals. Some people think it's cruel, but others believe this is the safest way to make sure they're not dangerous for humans. So carrying on, after it's been tested on animals, it's tested on humans. Okay, it's done in something called a clinical trial. And there are 2 groups of patients. Here's group 1, here's group 2. The first group is given the new drug, and the other one is given a placebo, which is so the patient expects the treatment and feels better, even though the treatment isn't actually doing anything. Scientists sometimes test new drugs against the best existing treatment rather than a placebo, so you can compare both of them. And they are blind, so you'll blindfold on both of them. The patient doesn't know. Okay, so my phone just decided that it didn't want to film any of this on the whole page, but you haven't seen any of it because apparently I didn't have enough space. So now I've made space, we get to go through it again. Yay! Now, so let's go through it again. So we got up to about the blind trials. So there you go, they're wearing blindfolds. So they don't know if they've got the placebo or the real drug. And it's considered double blind if neither the scientist or the patient know which one they're taking. Okay, on to drugs. Drugs are substances which alter the way the body works. Some are medically useful, for example antibiotics, but many drugs are dangerous if misused. So you can buy some over the counter, but some you can only get on prescription, for example antibiotics. Some people get addicted, which means they have a physical need, and if they don't have it, they get withdrawal symptoms. Same effect you get with coffee, right here. And the symptoms of this include shaky hands and irritability. Tolerance develops with some drugs, and the body gets used to having it, so it needs a lot more, a higher dose to give the same effect. So some of the drugs we need to know about are depressants, which decrease the activity of the brain. Look at my amazing picture of the brain there. And examples include alcohol, some beer, some wine, and we have alcohol and temazepam. And drink driving is dangerous because it slows the reactions down. Another example is stimulants, which increase the activity of the brain, so they do the opposite to suppressants. Examples are caffeine, nicotine, which is in smoking, and ecstasy, and they're often used to treat depression. Third one is painkillers, for example aspirin and paracetamol, which reduce the number of painful stimuli at the nerve endings. Number 4, performance enhancers, for example steroids, which help build muscle. I know how much this looks like a chicken, but it's definitely some muscles. Yeah, definitely. And it allows athletes to train harder, but most sports organisations ban steroids. Finally, the last one is hallucinogens, for example LSD, which distort what's seen and heard by the brain and alter the messages are sent along. Okay, finally the last bit that you missed. Okay, so we have 3 classes of illegal drugs in the UK. So first is class A, which is LSD, heroin and cocaine. And if you take or were supply these, you could get a lengthy prison sentence. Class B, cannabis and speed. And finally Class C, which is steroids and tranquilizers, which will probably only get you a warning, but if you apply them, it will also be present symptoms. Next section is about alcohol. Okay, alcohol. Alcohol is a depressant drug which reduces the activity of the nervous system, but the positive side of this is it makes people feel less inhibited. So it allows people to socialise more if they're drinking. People and friends. Wouldn't think this way. I'm taking off for GCSE. Yeah, with my great pictures. I haven't even got eyes. Great. So it helps people to socialise and relax. However, it is poisonous. And it's poisonous because alcohol, if it gets into your bloodstream, it's broken down by enzymes in the liver, and some of the products are actually toxic. And if you drink too much over a long period of time, these toxic products can cause the death of liver cells, forming scar tissue that stops blood reaching the liver, and this is called cirrhosis. And if the liver can't do its normal job of cleaning the blood, dangerous substances start to build up and damage the rest of the body. Alcohol also causes dehydration because it takes away some of the water, which can damage other cells in the body, including the brain. These are the symptoms of being drunk. Okay. Impaired judgment, poor balance, slurred speech, blurred vision, and sleepiness. Which is why you're not allowed to drive, fly a plane, or operate heavy machinery when you're drunk. Very smart whoever put that law in place. Okay, now I'm going to change my pen. I'm going to go on to smoking. Okay. Smoking produces nicotine, which makes it addictive, carbon monoxide, tar, and particulates, which all cause illness and other problems. For example, heart disease. Carbon monoxide reduces the oxygen capacity of the blood, and if the heart muscle doesn't receive enough oxygen, it can lead to a heart attack. Number 2, cancer of the lungs, throat, mouth, and esophagus, I think. But many organs. How this happens is the tar from the cigarette smoke collects in the lungs. There it is, collecting in the lungs. And it's full of toxic chemicals, some of which are carcinogens, which cause cancer, which makes mutations in the DNA more likely. If this happens, cell division can go out of control and malignant tumours, which remember are worse ones, can form. And finally, the last one is a smoker's cough and loss of lung function, which damage the cilia, which is on the trachea, that little hairs. Yes. So it can damage them, which encourages mucus to be produced. It's mucus. But excess mucus can't be cleared because the cilia are damaged, so it sticks to the air passage, causing a cough.